In this last composition of functions video, we're going to look at finding compositions of functions, but then also stating what the domain of that composition of functions is. So we're going to start here with example 6, and it asks us to find f of g of x and then state its domain. So as far as the algebra of this is concerned, finding f of g of x shouldn't be too tricky for us because we can see that f is just simply x squared plus 5. And so I'm replacing wherever I see an x with g of x. And then I have g of x squared plus 5. But then, of course, g of x, we know, is the square root of x. So we end up just taking the square root of x squared plus 5. And so that simplifies to x plus 5. So we could say a simplified version of f of g of x is x plus 5. Now, of course, if I look at this function here and just taking it at face value, if I was asked what the domain of that function is, I would say that the domain would just simply be negative infinity to infinity, right? Because I'm not going to divide by 0. There's no variable in the denominator. And at least at face value, I'm not going to take the square root of a negative, right? So those two things that we check for when we're finding the domain don't seem to appear. But if we take a look, let's take a look at our graphing calculator here. And let's go ahead and type in these two functions. So first of all, x squared plus 5 and the square root of x. And then what I can do if I want to look at the composition of these functions is define my y3 as y1, so alpha f4. So hit alpha f4 and then find y1 and press enter. And then in parentheses put y2. So alpha f4 y2. And you can see the function notation working here. So I've got that composition of functions, and let's deselect the two individual. Actually, let's keep them selected. And let's go ahead and graph all three of these. Okay. So as you can see, we've got our x squared plus 5, our y equals the square root of x, and then here is x plus 5. But only the part of y equals x plus 5 that is to the right of the y-axis is showing. And so what we can see here is that the domain of the red graph is only from 0 to infinity. And it seems like the y equals x plus 5 function also is following that domain. So of course what's happening here is that even though f of g of x equals x plus 5 looks like there aren't any domain issues we need to worry about, the fact remains that when we are doing this composition of functions, we're still sending x values into g first. And the fact that it's simplified algebraically doesn't change the fact that we're still having to put values directly into the square root. And of course we know we can't put negatives into a square root. So I think a helpful thing to do here is to go back to the diagram where we say if we want to look at f of g, then what we're really doing is we're taking x's, we're sending them into g first. They're coming out as g of x. Then we're sending them into f, and they're coming out as f of g of x. So regardless of how it simplifies, we need to check this inner function, this inside function, and see if there's any domain restrictions on it. All right. So here's how we would kind of summarize that. The domain of f of g is a set of all x in the domain of g such that g of x is in the domain of f. Now that's kind of a wordy, mathy definition. And so let's look at example 7, and this will kind of help give us a way to approach this really systematically. So again, I'm being asked for f of g of x. So f of g of x is going to be equal to, instead of x's here, I'm going to put g of x's. So g of x over g of x minus 3. All right, so we're going to do two things here. We're first going to check to see if there's any problems, just simply based on the fact that we're plugging g of x in to the function f. And so I can identify a potential problem here. We can see that there's a possibility of us dividing by 0. So over on the side, we'll say, let's make sure that g of x minus 3 is not equal to 0. Which means we need to make sure that g of x does not equal 3. But of course, g of x, we can go ahead and substitute that in there. So g of x is the square root of x minus 1. And this is a fairly simple equation that we can solve without much trouble. And then, of course, we can square both sides to get x all by itself. So we see here that x should not be 16. So on the one hand, I'm noting we need to make sure g of x can't be 3 so that we don't end up dividing by 0. But on the other hand, we also know that because we're taking f of g of x, that we are really sending x values into g first, then we're sending them into f, and they're coming out as f of g of x. So we also have to check g specifically. So when we look at that inner function, does this have the potential to either make me divide by 0 or take the square root of a negative? And of course, dividing by 0 is not a problem here, but I do see that x needs to be greater than or equal to 0. So we're checking the domain of the inner function. So I then combine this with this, right? I combine these two pieces of information, making sure that g of x does not cause problems when I plug it into f, and then making sure that the domain of g is itself honored in our domain. So if I want to make a number line out of this first, I can do that. So here's a number line. So it looks like we're starting at 0, but then we're going to get interrupted at 16, right? So starting at 0, greater than or equal to, so I'll use a solid dot, and then we go up. But then right at 16, I'm going to stop because I don't want x to be 16, because otherwise that'll cause me to divide by 0 here. So this would be 0 to 16 with parentheses on the 16, and then 16 to infinity. So that's the domain of our composition of functions. And we haven't even found and simplified f of g of x yet. We just plug g in. So if ever you're just simply asked to find the domain, you can really just go this far and that's it. But they did want us to find the implication here is a simplified version of f of g of x. So then I'll just go ahead and press on here. So instead of g of x written here, I'll put in the square root of x minus 1. So we get the square root of x minus 1 divided by square root of x minus 4. And that is our f of g of x. And by the way, you can see from this simplified version as well, and so another approach to this is just to look at the simplified version and note where problems arise. So you can see if you let x be 16, then you're in trouble, right? So this simplified version would have also led to that equation for us to solve. So there's our simplified f of g of x, and here's our domain. All right, one last example where we'll look at this. We'll find f of g of x and g of f of x and state the domain. This would be a good one to press pause and try these on your own first before you take a look at my solutions. All right, so first of all, for f of g of x, I am in f replacing x with g of x. So right off the bat, I can see I need to make sure that g of x is not equal to 0. And so that would mean 1 over x minus 2 is not equal to 0. But understand that there's nothing that would make 1 over x minus 2 be 0. So this little equation we're trying to solve isn't yielding any solutions we need to worry about. So no x makes g of x equals 0. So we're okay there. But I go ahead and continue to look at the domain. And so we need to check the domain of the inner function. And that does have something we got to watch out for. Right? We want to make sure that the bottom of this fraction is not equal to 0. So x minus 2 not equal to 0, so that means x should not be 2. So this is the only restriction that we have, so our domain is everything except 2. So negative infinity to 2, and then everything from 2 to infinity. And then just to finish up here, let's replace g of x with replace g of x with 1 over x minus 2, which is equal to 1 times the flip of this fraction. So we can see that f of g of x is just simply equal to x minus 2. So here's another case where if you were just looking at the simplified version at face value, you might think, oh, there's no domain restrictions. However, because we know we have to check the inside function and make sure we're not dividing by 0 there, we learned that, oh, we can't actually let x be equal to 2. All right, and then finally, g of f of x. So this is going to be 1 over f of x minus 2. And so for starters, before we even simplify further, we can say, all right, I need to make sure that f of x minus 2 does not give me 0. And of course, f of x is 1 over x. So we have this equation for us to solve. 1 over x does not equal 2. That means 1 does not equal 2x. So x better not be equal to a half. But on the other hand, we've also better check the inside function. Check the domain of f of x. And so that's a pretty easy one to check. We just need to make sure that we understand that x equaling 0 is problematic. So we can put those together into a single domain where we let x be whatever it wants to be so long as it's not 0. and so long as it is not 1/2. Just pluck 0 and pluck 1/2 right out of there. And then finally, let's finish simplifying. So f of x is 1 over x minus 2. Here's one where I think it's handy to multiply on the top and bottom by the LCD, which is x. So multiply by x over 1 on top and bottom. And so this becomes x over, of course we distribute, x over 1 times 1 over x is 1, and then minus 2x. And like in the last problem that we did in example, what was it, example 7, we can see that this analysis we did here is actually quite apparent right here. We can see we want to make sure 1 minus 2x does not equal 0, which is basically where we ended up here, right? By saying 1 should not equal 2x. So we can see x equals 1/2 is a problem.